An inductive proof does not just show how we know a given mathematical method is true. It fully derives that mathematical method from reality by showing the motivation for that idea, which means some particular problem one might face in real life that would lead one to develop that mathematical method. Today I'm going to demonstrate that principle by telling a story of a situation where someone would have needed a method for simplifying fractions. So let's go further into the story of how an integrated system of fractions could have been developed here on Inductica. Let's start with Unit 1.17, multiplying fractions by whole numbers. Bar is, remember, a shopkeeper in Babel, and he sells parashan hardtack for 3/4 of an iron coin each. So he has come across a situation where someone wants 10 pieces of this hardtack. So the question is, how many iron coins must this person pay if each of them costs 3/4 of a coin and they want to buy 10 of them? So this leads Bar to the following general question. How does one multiply a fraction by a whole number? Investigation. So the problem that Bar has to do is basically 10 times 3/4. They have to pay 3/4 of a coin 10 times. So how does that work? Well, this is actually very straightforward. All Bar has to do is multiply 10 times 3. Why? Well, because there's actually only 3 units here. Remember from our prior video that the number on top of a fraction represents the number of units. So regardless of the size of these pieces, there's only 3 of the pieces, and he's got to pay the 3 pieces 10 times. So it's just 3 times 10, which is 30. Okay, and he uses multiplication in order to find that. All right, now 30 of what? It's 30/4. So we have to put the 4 down here, okay? What does that mean? It means that these pieces are of such a size that 4 of them is required to make a whole. And so that's his answer. It's really that simple. Conclusion. To multiply a fraction by a whole number, simply multiply the numerator of that fraction by the whole number. Next, this brings us to Unit 1.18, the simplification of improper fractions into mixed numbers. Motivation. So the price that Bar has for 10 pieces of parashan hardtack was 30/4. Now finding 30 quarter coins is going to be a pain. So he wants to find out how many whole coins he can represent this with. 30/4 is going to be the same as some number of whole coins. So the question is, how can one simplify an improper fraction into as many whole units as possible? And this ends up being called a mixed number. Investigation. Bar is trying to figure out how to write this in as many whole units as possible. And he comes to a realization. For every 4 of these units, there is 1 whole. And he knows this because of the nature of fractions. Therefore, all he has to do to find the number of wholes is to simply divide 30 by 4, and that will show him the number of wholes. Now, when he does this, 4 goes into 30 7 times, with a remainder of 2. Well, there's a remainder of 2, it's 2/4, but he realizes that he can actually use perfect division, division without remainder, where we actually get a fractional quotient to find out how many partial coins that can't be united into a whole. And so using that prior method of division, he gets 7 2/4. Conclusion. To convert an improper fraction to a mixed number, simply divide the numerator by the denominator and conduct perfect division. Finally, this leads us to Unit 1.19, simplification of fractions. Motivation. Bar sees that part of this price that he has is 2/4. Now, he knows from common sense that this is 1/2, but he wants a general method for converting larger fractions with larger numbers of units and smaller unit sizes into more simplified fractions. So this leads Bar to the following question. How can one systematically reduce a fraction to the fewest pieces of largest size? So just visually, Bar is able to see that 2/4 is the same as 1/2. So you can see that pretty easily visually. But he wants a general method by which he can make fractions simpler. So in order to understand this, he's going to start with 4/6. Now, once again, looking at this intuitively, he simply can see that this looks the same as 2/3. He can just see that it's the same as 2/3 if he draws it carefully. But he wants a systematic way to write any fraction in terms of the smallest number of pieces, each of those pieces being of the larger size. You can see in this change, the pieces got bigger and the number of pieces got smaller. So this is simplifying the fraction. We don't have to chop things up unnecessarily in order to make exact change. So Barr realizes that what he's doing implicitly when he makes this conversion is he's joining these two pieces and these two pieces. So every two pieces are getting joined into one piece. And so what that's equivalent to, that is equivalent to dividing the numerator by 2, because there's now half as many pieces since every two pieces turned into one piece. Now, it's also equivalent to dividing the denominator by 2. Why is that? Well, the reason is because each piece is getting twice as big. Two pieces are being joined into one. So each piece gets twice as big. As a result, the number of these pieces required to make a whole is divided in half, and thus we divide by 2. To demonstrate this principle a little further, let's do one more example. Let's consider the fraction 9/12. Now, Barr is never really going to chop coins into this many pieces, but he wants to be ready for any fractions that might come up in the future. So he's going to work out an example to make sure that this principle generally applies. He realizes that he can divide both the top and bottom by 3. Let's rewrite this so that he can divide. He divides the top by 3. And what does that mean? It means every 3 of these is joined into a unit. And so now there's only 3 of such units. Further, because each of these 3 units is joined into one unit, the number of these new units required to make a whole is 3 times less, which means you divide the denominator by 3. And since every 3 of these 12ths were united together, they created a 4th because the units are that much larger. And the final result is 3/4. Conclusion. To change a fraction to an equivalent quantity, which involves the smallest number of units, the smallest numerator, and the largest sized units, the smallest denominator, divide both the numerator and denominator by some number which divides both perfectly. As I've demonstrated in past videos, to fully induce a concept, it's not enough to just show that the idea is true. You have to show the kind of situation which would get someone to care about investigating and inventing that idea. We need to justify the idea, not just epistemologically, but practically. In today's story, Barr was motivated to multiply fractions by a whole number because he sold 10 units of something that had a fractional price. Next, since the total price was an improper fraction, he was motivated to find a way to reduce an improper fraction to a mixed number, since a mixed number was easier for a customer to pay. Then, upon seeing that his mixed number contained the fraction 2/4, he was motivated to come up with a way of reducing fractions to the smallest quantity of the largest possible units, again to make the price easier to pay. So join us next time as Barr uses his method of changing the way fractions are written to add and subtract fractions with different size units. I'll see you then. This video is part of a longer series dedicated to reproving the essential ideas of math and physics by showing an actual process of observation and reasoning steps scientists could have taken to prove these conclusions. Observational proofs, also known as inductive proofs, give us a deeper, reality-based understanding of these abstract ideas and demonstrate the proper method of scientific proof. This series starts with cavemen counting rocks and will continue all the way to the frontiers of quantum and relativistic phenomena. This epic story will proceed in a possible order of discovery, since science always progresses by reasoning about observations using what has been discovered earlier. To discover the long-term goal and the true power of this project, visit my channel page for more information. To see the playlist for this series or to see my channel, just click on the links on the screen. Finally, if you'd like more lectures like this, just go to patreon.com/Inductica. For just $5 a month, you gain access to the written, rigorous forms of these proofs, as well as my 34-hour lecture series an inductive summary of physics. I'll see you in the next video as this inductive journey continues.